Yeah, well, the story that Mark's referring to is a time when I was a defense company making parts for the F-22 aircraft, and we knew our contract was ending, and it was my entire company. And so I was faced with an existential challenge in that I had to replace approximately $20 million US a year of business, and I had roughly 5 years to do it. And the reason I think it's pertinent, to give a little more context, I think, before we go into it, if you're a company today and you're looking at this opportunity of a lifetime to go into the defense sector, first of all, it's a vast market, and defense is non-specific. Defense can be so many different aspects, and so you do need to understand your market. And I think the story really is about understanding your value proposition. And so I really want to make sure I give a little context, and then I'll explain how we approach this particular challenge. In our situation, we were drilling holes in parts for the F-22. They were very, very precise holes. They were very specially shaped holes for reasons that are pretty obvious to everybody at this point, but we couldn't have talked about then. And some of the holes had tens of thousands. Some of the panels that we made had tens of thousands of shaped holes in them. One bad hole killed the panel. And so we were a world-class driller of holes. Because we had a $25,000 piece of material on a water jet for 100 hours to drill 26,000 holes, we had to have an extraordinarily tight process control. We had to understand our process, and we had to own our process and control our process. So we had some real quivers, arrows in our quivers, so to speak. And so when we were looking at a pivot, which is what many of you are looking at right now to come into defense, what we had to look at first is, okay, exactly what is it we do that creates value, and where can we play in other markets? And I think it's really important, because superficially you would have said, okay, we're a defense manufacturer. We make airplane parts. They're really precise. They're titanium or Inconel because they're very hot parts, and they have lots of holes in them. Let's go find other airplane parts that look just like them.
Yep.
There were no other airplane parts that looked just like them. And at that time in the US, the defense budgets were being cut. We were well into the back end of the peace dividend, and there was no place to go. But what we did is we took a step back and said, okay, these are the things we do really well, and this is how we provide value. And so what I did is I sent all my engineers and my salespeople to every trade show for every industry we could find. And I said, I want you to take pictures of parts that have holes in them. I want you to take pictures of parts that are tightly spec'd and require real precision manufacturing controls. And I want you to bring them back. And what we did is we looked at things that we thought fit our process capability, not the type of parts that we made. And when people would say, oh, but we're an aerospace manufacturer, we're a defense contractor, I would say, take that part from the F-22 and bolt it to the back of a trash truck. Is it a fighter plane part or a trash truck part? When it leaves our shop, how do we know? And does it really matter? What we do is we cut holes in metal. And so what we did is we found a bunch of different markets. And then we looked at those different opportunities and we said, okay, which of these will meet our financial requirements? Which of these will give us enough of a production run to offset the F-22 work? And we ended up landing on drilling holes in nozzles for GE land turbines. So there are nozzles and they have diffusion cooling holes in them to keep, because the hot section of the turbines runs hotter than the material can take. And so what you need to do is you need to run cooling air through now the cooling air is about 700 degrees Fahrenheit, but that is much cooler than the environment of these parts. And what we did is we said, okay, these are parts that have holes drilled in them. They're very, very precise holes. They require extraordinary process control, and they're tightly spec'd. And we said, okay, that's our meat. And we ended up spending a couple of years figuring out how to make those parts. And we ended up doing something nobody else could do. We did something for General Electric that no one could replicate for a number of years. And we went into production, and we were then an energy company. So by the time the F-22 program had ended, we were no longer a military aircraft parts company. We were at that point largely an energy company doing work on turbine nozzles.
With expertise now, because you presumably before you were taking a titanium panel, you're now dealing with a casting that's presumably not very accurate. It's a very different, but you still need to put these holes in exactly the right place. So presumably there were some challenges in moving to a kind of, everything looked different, even though it had very precise holes in it.
And then again, we were a crackerjack engineering company. And so because all of our work was highly engineered and process, and our processes were tight, we ended up designing new pieces of equipment that we spec'd that had the combination of stiffness, elasticity, and 6 axes of motion that we could actually make the parts that we needed to make. And then we hired a professional in machine motion design, a PhD out of the University of Florida, who actually created software for us so that we could take a nozzle, which was not precise in terms of location because it was a cast nozzle with coatings on it, and it would actually put it in the tool and it would probe it and map it, and it would find exactly where the airfoil surface of the nozzle was relative to the nominal CAD, and we would actually best fit it and remap the cutting program to a new morphology. So actually every part was uniquely made to fit the casting as it was manufactured, and we then really redatumed it to the as manufactured casting. But again, what we had engineering capability, and we constantly were designing our own equipment because we were always trying to make our equipment do stuff nobody else could do, and that was our source of advantage. But I think more fundamentally than that, though, because that was a special company that had that ability, I think what I would tell companies is know what you're good at and know what you're not good at. When you look at manufacturing processes, everybody tends to look at what's going on the floor. You need to look at your back office. You need to look at your paper. You need to look at how you go to market. You need to look at how you interface with customers. How do you handle specs? How do you control data? All of these things are the inputs and outputs of your business. The people on the floor are fantastic, and give them a good drawing, give them a good model. Your engineers can figure out a lot of that stuff. But especially if you're not in defense, what you need to understand is the paper is every bit as important as the part. And there's an old quote from a person most of you guys have probably never heard of. His name was Donald Douglas. He was the founder of Douglas Aircraft, which became McDonnell Douglas, which is now Boeing, for anyone old enough to remember this. But what Donald Douglas said that I always thought was intriguing was, when the weight of the paper is equal to the weight of the airplane's ready to fly. And what I think when we talk to automotive companies are world-class manufacturers. On the floor, pound for pound, better manufacturers than aerospace manufacturers. They have the scale and the production runs to take processes way further and make money that way than an aerospace company does. If you're making tens of thousands of parts, you're automated. You've got so much data. You've got Six Sigma because you've got so much data to feed it, and you've got an amazing base, but you're not going to be as strong in terms of paperwork as someone who's doing aerospace parts. And so you're going to have to look at that, and you're going to have to make sure that from a compliance standpoint, you understand configuration control, you're certainly going to have to understand document control and ITAR and how material information has to be controlled on your floor, revision control, MRB controls, and a lot of other elements that go into becoming a true defense manufacturer. And those are the things that you're going to find are going to be your biggest challenges. So you're going to have to look at your processes, but not only your floor processes, you're going to have to look at all of your back office. And so you're going to want to make sure that you understand what that looks like in a defense contractor. And you're going to have to add costs because you're going to have to either bring in new people or you're going to have to bring in training to create this skill base you need to be effective. And it's it's cliched to say it's a journey, but it's a journey in that this isn't going to happen overnight. This is something you're going to need to commit to, but this is a generational opportunity because the Canada of 10 years from now, from an industrial manufacturing standpoint, is going to be a much different Canada than the one of today, because we are finally identifying the need for sovereignty in terms of the things we can make. And we're looking internally to make things to sell to one another. And the look east, look west and build here is going to become, I think, the future of Canada. And so it's a journey, but it's a journey you're going to want to undertake, and you're going to want to start at some point. So might as well start early, because the work is going to be there, the opportunities are going to be there, and the things that have changed in our world are not going to go back. They're just not going to, it's not going to be like it used to be. And frankly, it's in our interest that it not.
So it's kind of good news and bad news for getting into defense. So the good news is it's actually going to take some time. So you've got time to get into it. But also, I think you were stressing that it's bad news if you're a kind of company that needs rapid returns, that might mean that the defense cycles are not going to be so good for you as a company. But everything is fundamentally built on capability. And when we talk about dual use, we should really think about what's your core capability, and looking at it that way is a broader way. By the time we get to use case, we can kind of pigeonhole it. You said when we tried to look for another panel that looked exactly like our panel on the F-22, there just weren't any. And that's maybe a good sort of way to frame dual use. If you're trying to look for something like that, you're probably looking in the wrong place. You need to go maybe back a little bit down the TRL levels. I know it's a really nerdy conversation that we're having up here, so apologies if we're boring you for this. But tell us a little bit. You did quite a bit of work, Stuart, on the opportunities for defense and where Canada spends money. What did you from this data? Can you kind of try and summarize it in words for us, where you see the opportunities, the different levels of risk and reward?
Yeah, Canada, we are doing a lot of work in defense. We have some great companies like MDA, Rochelle, GM is doing defense work, Bombardier is doing some defense work, MHI. There are a lot of companies here in Canada that are doing defense work, and they're all looking to grow, and they're all going to need great suppliers. So the first thing I would say is pay attention to who you're already doing business with, and find out what they sell and to whom, because some of your customers may already be dual use, literally dual use, legitimate suppliers, and if they're going to look to grow, they're going to need you to grow with them. And so if you have well-established relationships that are based on your capability, certainly understand your customers and their customers better. That is low-hanging fruit toward moving along the journey. Also, talk to your suppliers. The people you buy materials from, the people you buy processing from, the people you buy packaging materials from are going to have relationships with others. And again, in some cases, those relationships will open doors for you. So the one thing about defense is this is a relationship business. Defense cycles are long, but they're not cycles where people are looking to change out suppliers every year for 2%. They're relationship-based, they're capability-based, and they're incredibly risk-adverse. So, you do the work and you build the relationships, and you can build partnerships then that create sustained revenue streams for your company that are scalable. And they're very unlikely to come back and say, okay, you need to give me a 2% reduction next year or I'm moving the work. The cost to move a controlled product and controlled process is extraordinary. So the equation is a little bit different. So be prepared to spend some time, but it's worth it. If you embed yourself, and if you're a great supplier, you'll have an opportunity to support Canada in the defense sector or the dual use sector. But words matter also. Dual use means something really specific legally. Multi-use is much safer. But if you say something's dual use, make sure you know what that means, because there are legal requirements around those things. And a story I tell to give an example of how insane some of that stuff is, at least that I think is funny. When I was a research engineer at Northrop Grumman, we were doing research into advanced composites. And this was very early in the time of advanced composites. They're very common now, but in the 1980s, they'd never been flown by the U.S. Air Force. And we built a landing gear door for a T-38, which is a trainer. And I was at Northrop, and Northrop owned the airplane. And so we built one out of graphite. And we decided we were going to convince the Air Force to fly it so we could take pictures of it and be the first ones in the air with a composite component. We were working on an airplane called the YF-23. And what we were really trying to do is figure out what we were going to make it out of. And what we needed then was to get composites in the air and find out whether they would really last in a real environment. What would happen when they got banged up? How could you fix them? How strong would they be? But one of the people on our team happened to have drawings from this T-38 landing gear door in their satchel, and they went into the project area. Once it was in the project area, they took some papers out of their satchel. Somebody came along and classified the drawings. They stamped them all classified. We now have a completely unclassified part that is sitting out in a display room at the company that has now been classified. And you can't just say, hey, it's a mistake. We're going to have to go back and declassify it. So what do we have to do? We had to run to the other side of the company, grab the thing, pull it back and lock it up, find everybody's drawings, pull all those drawings and lock them up, and move all of the files from the CAD into a different server, because we now have a classified part in an unclassified space. Which seems really silly, but that is how important getting your paper right is. And then we had to go through a formal declassification process at great expense to declassify something that was completely unclassified, because you couldn't just say, hey, erase that. It is not that simple. And so if you've been in the sector, you'll understand that, and you'll understand why that was a problem. And if you've never worked in the sector, then you really have to pay attention to words when you're dealing with defense goods. So do be thoughtful about dual use and controlled goods, and because you could also borrow trouble you don't need. And a lot of things you can sell to national defense are multiple use, but they're not dual use. And you can still do business with national defense, and you may not need some of the other controls and constraints, and you might not need the registration. So understand the market. It is a vast market. It is a complex market, and it's a nuanced market. Understand the market. Understand where you're already adjacent to the market. That can be what you do and your processes and your capabilities. It can be who you do business with. And then make a business plan.
But as you said, it's a relationship business. It's not going anywhere. I'll tell a story just to give you a break. But I used to make parts for Rolls-Royce in the UK, Rolls-Royce aircraft. And the sexy parts to make were for the civil engines. And we wanted to be on the civil engine programs for the Trent 800, 1000. But all of those programs got moved around really easily around the world. And it was kind of a race to the bottom, and Rolls-Royce would come along. I'm allowed to say this now. The statute of limitations has passed. But they would come along and they would demand, 30% cost down over 3 years. And you're like, how are we going to do this? Because we were totally dependent on them. But we also made defense parts for Rolls-Royce, which we didn't like making at all, because they were low volume, they were really complex. We had to send them out for lots of processes. But somebody said to me, Mark, those parts will never go to China. They'll never go anywhere else. And I had never thought of it like that. And again, it's, what you're saying with the, once you're into defense, you're probably in for the long term. So it is a great place to maybe build another leg to stand on for your business. And you've probably, as you say, you've probably already got people, some of your customers who are already there. I want to segue, if we can, a little bit. We're here at Hannover. It's all about the future. We have robots everywhere. We have AI everywhere. We've talked about process excellence and sort of, that being a reliable supplier is going to be critical to being in defense. You're going to have process capability. there's a book called Thinking Fast and Slow, where the author explains a planning fallacy where we always think that it'll be different for us and we'll be quicker than everybody else. And one of the things throughout my manufacturing career I found is that we're not very good at planning. And I'm wondering, Stuart, what your take is on, will AI help companies become more capable? How do you see AI helping with capability?
I mean, AI again is vast. First we have to define capability. AI is an amazing way to make sense of data. People in manufacturing companies, we all have data, but data in and of itself isn't necessarily very valuable. Data has to have context. You have to understand where it came from. You have to understand how accurate it is. You can't make you can't make decisions that are beyond the fidelity of the data that you're basing it on. AI offers a great opportunity to make sense of the data and information you have within your company. But if you don't have good data, AI will help you go broke really fast. And so, when we talk to companies about digitalization and Industry 4.0, we always say, how are your processes? Have you mapped your strategic core processes? Do you understand them? Are your processes controlled? Are you lean? Have you done value stream mapping? When you look at information flows through your organization, you have to remember that data without context is noise. Data in context may be information, but only if you know how good it is. And data in context that has been qualified becomes knowledge. And knowledge can now be married to process to create throughput. And AI can operate on that knowledge. But AI isn't going to create data where there is no data. And if you let it, you're going to get junk. And the challenge with this Industry 4.0 versus Industry 3.0 is it's not plug and play. There's a much bigger opportunity here, but it's a process opportunity, it's not a plug one machine for another machine. It's not replace a person with an AI. AI and people are really different. We'll need both. It's a tool. And one, you do need to understand how to use it. But before you use it, make sure you have your processes mapped. The biggest opportunity I think a lot of companies are going to find with AI is look at how your back office works today and look at all of the steps and stops and processes that were all designed around people's limitations of knowledge. Because companies look the way they do because you had someone in purchasing or someone in planning, someone in scheduling. They all worked on information with their own context. And so you had to have all of these process steps to get throughput in your company. The stuff on the floor was the easy part. Revisit all of that in terms of how your organization works, because the expertise is now completely portable. Because the AI can do so much of that for you. You can build a lot of that into your processes and you can collapse your processes. At a company that I was running a few years ago in the Vaughan region, we digitalized our back office processes and we had 16-week lead times and we were turning around aerospace parts in 3 days with full certs, full FAIRs. In a 70-person company, we did 135 FAIR packages in a month. And what we did is we used information and we remapped the information from the customer's drawing to our floor and looked at every decision we made and why we made it, and we collapsed it. And we found out that we were mentally picking up and putting down the same part 6 times over. The same way when you would look at loading and unloading a part, a different person had to look at the part and was asking similar questions.
That's a great analogy, isn't it? Because we're all familiar with, the waste of loading and unloading. But you say we kind of do that in an organization with information, with each decision is loaded and unloaded.
Are we going to quote it? Somebody looked at it. How much is it going to cost? Somebody looked at it. How are we going to tool it? Somebody else looked at it. How are we going to do the programming? Somebody else looked at it. How are we going to inspect it? Another person looked at the same part. We realized that was incredibly wasteful. We could do all of that once and never have to do it again. And the part could go through our floor and out the door. And when it hit the floor, it was ready to ship. All we had to do was make the part, which was the easy part. So what I would tell people is, if you're trying to take advantage of all this opportunity, pay attention to your processes first, and then look at the opportunities of the technologies to improve your throughput, to shorten your cycle times, to make your processes more controlled and more robust, to make better use of the data you collect. And if you're collecting data and you don't have any way to use it, stop collecting it. So unused data is another form of waste. And so make sure you're getting the right information and that you're using it in context to drive process. And if you take that mindset, I think there is so much here that can improve your operations, and it's all about throughput.
I think that's a great way to wrap it up, Stuart. Capability, process, throughput. Thank you so much for sharing those stories with us today, and thank you guys for listening. Thanks, Stuart.
My pleasure, Mark.
Thank you. Thank you. projects for NGen. Rob, we both, funnily enough, started our careers in industry in tool making. I was a CAD/CAM programmer, taking my mistakes to the welders for a bit of early additive manufacturing adoption. Tell us a little bit about, your first bout in industry.
Yeah, so I started my career off as a mold designer at Husky Injection Molding Systems. And funny enough, I started there as a student and really came to understand the technology working there my summers and so on. And then when I graduated, became a mold designer. And I found that really interesting. Again, the design part was interesting. But I'm not going to lie, I really was excited about the manufacturing plant. And at that time, Husky was always, and Husky continues to be this way, but they always invest in new technologies, improved technologies, always finding a better way to deliver value. And so I was just fascinated by the factory floor. And it just so happened that about a year after I started as a designer, there was a need. Husky was expanding, and so it got me out into a different role. And that started my life in manufacturing, where I was doing a lot of the factory planning and then integrating with the manufacturing floor and really understanding their needs. And yeah, I grew up at Husky. I spent a good almost 25 years there, and it was fantastic to really understand the manufacturing side of mold building and tool making and all the nuances there and the incredible technologies that were just continued to grow so quickly in that time. But yeah, fantastic way to start my life.
Same with me. I trained as an engineer, but I really fell in love with manufacturing, and I'm still very much in love with it. And I think one thing I'd like to just bring out with NGen. I think people think of NGen as this big pot of money, and it's a little bit like Marmite. Sometimes you kind of love it if you get some, and then you're really turned off if you don't. But NGen's the entire staff of NGen are industry veterans, aren't they? And I think it's fair to say you've made a few mistakes along the way, haven't you? And while you can't directly coach companies, the human side of NGen is incredibly important to a successful project. But of the sort of 250 projects that NGen has done, I know it's like picking your favorite child. We're not allowed to do that, but can you tell us about one that stands out to you?
Yeah, so I mean, there's so many, like you said, Mark, that are special for different reasons. I think the prototypical really great NGen project is where we have like a technology provider, an SME, that partners with a large industrial manufacturer. In those cases, that situation creates great market pull for the tech developer. It creates a forum or a location where they can prove out their tech in collaboration with this large manufacturer. And then, again, it gets them an opportunity to scale and commercialize this great new tech, and then the large manufacturer gets a great solution. So one of the really cool examples there is when Maple Advanced Robotics, out of Maple, Ontario, they partnered with Magna. And together, Magna was looking at a novel way to do some of their robotics programming for surfacing and so finishing some components. And Mari at that time was a tiny little company, and it was some really, really bright engineers. And that project really, really, I think, set a great tone where a tiny company working with a monolithic company like with Magna to collaborate.
A real David and Goliath.
Oh my gosh.
Isn't it? Yeah.
Absolutely. But Magna was a great partner, and they really provided great facility and feedback, and it was a great partnership in terms of the tech development. And the exciting part there, and this is the part where really I feel very proud, is those are early days for Mari, and we funded them. They were a tiny little company. Everybody knows Magna, so there's very little risk on the Magna side. But with the funding of that project, Mari continued to develop their technology, continued to grow. I mean, here at Hannover last year, they won the Top Robotics Award. Here's this tiny Canadian company on the world stage and doing a great job. And again, they won another award this year for their AI solution. So tiny company starting off with an NGen project and continuing to grow and scale. So that to me is probably one of my favorites.
You're a very proud parent.
I'm very proud of that one.
Yeah.
And I want to go back to your point as well. Like different perceptions of NGen. People ask me all the time, "Oh, are you guys government?" and so on. Well, not government. Most of us are ex-industry people. I spent more than 35 years of my life in industry, and I'm very proud of that. And I think with my colleagues, like it's important for us to really understand what's happening in industry, and because we were there, and we want to help. And most of us are at that point in our careers where we want to help these great new companies and great tech development continue to grow and be successful here in Canada. So that's NGen. It's really guys, old guys like me, and younger people that have been in different sectors, but bringing something to the table where working with these incredible entrepreneurs and technologies is great, but we see that sometimes we're going to make some of those classic early mistakes that maybe I've made in my life, and I love the opportunity to help them avoid doing some of the dumb things I've done in my life, and if that gives them an opportunity to scale up and be successful and get to happier times quicker, scalier, keep their IP in Canada, that just makes me proud, and I think that's what excites most of us here at NGen.
So it is a two-way conversation where you're mentoring these. So as you say, they don't maybe make some of the dumb mistakes that we've all made in our careers, and Stuart and I were talking about earlier on. But it's also presumably about navigating respond to something like that in Canada?
Yeah, so I think that one of the exciting parts of what we do is we really are tied into manufacturers across the country and technology providers across the country, and I've had a chance to visit with a lot of them, right from BC all the way through Ontario and the East Coast. I think that there's definitely Canadian capability. There's great Canadian technology and fantastic Canadian entrepreneurs. I think that the ability is there. I think what's and we've had conversations about what would it take, or what is defense looking like? What are they going to need? I think the will is there and the capability is there. I think what's lacking is a bit of the clarity. And we talked about UAVs, for example. I mean, that's a whole different kind of way of building a military force than classic old ways.
Presumably the UAVs that Canada might need probably are going to look different from the ones in Ukraine, although there are a ton of lessons to be learned from there.
Absolutely. Yeah, and that's part of understanding our sovereign needs. Like, again, we have a very large Arctic with very extreme conditions. So, yeah, I think that the inspiring part is absolutely that we have Canadian capability, and it's certainly a want to be in there. I think it's just lacking a bit of the clarity on what the demand's going to look like before anybody really invests heavily into it and pivots their factories into doing it. I think the picture just has to be a lot clearer. So I think that, in Canada we have predominantly mostly SMEs in that space, but the willingness is there. These SMEs want to scale up. They want to be there for the country, and that's a great news story. I think once things become clear, now that we have a defense industrial strategy and we have a little more clarity on how the investment dollars and what the strategic elements that we're going to be focused on in terms of building the defense forces, once that all becomes clear, I don't think you're going to have any difficulty seeing Canadian SMEs pivoting and trying to get in that space.
And just sort of, I know it's day one of the show here, but just in terms of technologies, do you see, certain technologies becoming sort of very strategic for Canadian infrastructure? Again, I'm asking you to sort of pick favorites yet again, but...
I mean, I think that there's some areas that Canadian technologies are world leaders. We've talked about AI. I mean, there's a fantastic AI technology here at the show already, and there's continuing to be more developed as well. I think that's going to play a major role, and Canada's absolutely well equipped with the researchers, with the technology in that sector. I think another one that's going to be interesting in the next 5 to 10 years is quantum. See where that plays in. I think that's where Canada has a distinct advantage with the companies that we have and the technology, and we're in the leadership of the world class. So I think that's going to be something of a bit of a game changer as well.
You see that beyond sort of, I know quantum's meant to be great for encryption, and obviously we're talking defense, and that's supremely important, but do you see quantum other applications? Can you make it real for us a little bit?
Without really divulging too much of the projects that we've funded, yeah, I mean, it's really the power to solve incredible problems.
Okay.
And so, I think that, on solving health issues and formulas and material science and all those things, which is all great for the civilian life that we all count on, but you can see that all that stuff would have a military application as well to solve some of those problems and solve some of the material issues that they're having. And so I do think that can become a core technology, and I think that's something that Canada leads in, and I think that, I would probably hazard a guess that in the 5 to 10 years they're going to be a bigger and bigger player. Robotics and things like that, I think Canada has outstanding technology in that space as well. I think that, personally, I think with SMEs getting into the defense sector, they're going to have to think of automation as a way of kind of, scaling quickly in case of defense, in case of emergency defense times. That if you had a baseline, you're not going to be scaling up to emergency times by adding more people. It has to be through working smarter with automation and with the kind of technology that we're seeing here at the show. And so I think those will be the keys that will be built on in the future.
Well, that's great, Rob. I think that's a great point to end on, some very, very practical advice for people, and you didn't have to pick your favorite child. Thanks very much, Rob.
Yeah, my pleasure. Thanks, Mark.
Thank you.
Thank you.
Haha. Ah, jetzt. Haha. So. So, dies ist ein Test des Audios. Dies ist ein Test des Audios. Dies ist ein Test. So.
For today.
Test, Test, Test. Test, Test, Test.
Oh, weißt du was?
La 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 la.
Good afternoon, everybody. Welcome back to the NGen Conversations podcast. This afternoon, broadcasting live from Hannover Messe and sponsored by York Region. I'm going to be your host for the next 20 minutes or so. This afternoon, I'm joined by Guillaume Deschenaux.
You got it.
From NGen. You're the CEO of a very interesting company working. We have AI all around us. It's obviously your life's work. Your company, you say, it's all about, first of all, identifying an opportunity. And, you know, the technology is an enabler. It's not the end product. Can you just
Elaborate a bit.
Elaborate a bit on that? You know, where do we begin in this sort of digital journey, and how does your company approach this?
Sure. So we've been in business since 2008, and really quickly, if you might not remember that, but in 2006, the first public cloud came out, right?
Okay.
AWS was started in 2006. It was really rudimentary at that point. We made our first workloads in 2009, and we worked with SaaS companies, big SaaS companies, startups. And
SaaS is software as a service.
software as a service.
Okay.
So technologies that were already, let's say, willing to adopt new technologies, innovate. That was in their DNA. Then later, let's say late 2010, the decade, we started to work with manufacturers, and we realized that they were super behind in terms of just cloud adoption at
Yes.
that time, and then AI is just even further,
Yes.
right? So what we try to do is when a manufacturer comes to us and say, hey, I would like to adopt AI, and these days they are all willing to adopt AI, but they don't know where to start, right? So what we try to do is to sit with them and understand, what do you have in terms of data? What are your pain points? What are your challenges? And with them, with the right stakeholders around the same table, we try to figure out what are the opportunities that they have to start using cloud and AI technologies to get value quickly.
Yes.
So avoid boiling the ocean, trying to do the big thing that never comes out, right? You spend money and it takes years to have some value out of it. So instead we start small and we iterate and we deliver value iteratively over time. So we start with doing some workshops with them, interviewing them on the various teams. What do you have in terms of data? Have you tried AI? What are the pitfalls you fell into? And then identify projects. When I say opportunity, I mean projects where you implement AI, or sometimes it's not AI, it's more like leveraging your data. It could be AI. AI for me, it's a means to an end. It's not the end itself. The end is bring value. I'll give you an example. We work with a bread manufacturing company.
What kind of manufacturing?
Bread and
okay.
pastries.
Yeah, okay.
And
So they have a flow line going, do they?
yeah, big company, they have conveyors, and
Yes.
you start with just the raw ingredients.
So you're mixing up dough.
And flattening it, sorry, and then eventually forming it into bread or croissant or.
So here we are bringing the production line to life here at Hannover Messe. Yeah. Okay, so
So they already do that, but sometimes, for some reason, the bread are too small, or the
Okay.
croissant don't have the right shape. If there's too many of those,
How do we say that in French? Mon croissants sont mal formés or something? Yes.
ils sont tout croche.
To crush. Very good.
So when there's too many items that do not respect, let's say, the specs, either the size or the shape, then they need to throw away the batch because
That's a big deal. Yeah. Okay. Yeah.
they can waste a lot of money with that. And they were measuring along the production line various data points,
Yes.
but they could not action fast enough to reduce waste to a minimum. So we just helped them leverage data that they already had,
Yes.
made a first small iteration on what they had to just analyze the data, detect when there's deviation coming,
Yep.
provide dashboards on the factory floor, provide alerting to people that can action on what's going on.
Was
And-
this vision? But how are we detecting that our croissants are going to be the wrong shape? Was it camera-based data, or what?
First
kind
step, no AI as sophisticated as that. So they already had people on the production line taking some samples,
Yes.
measuring it, assessing the shape, taking some notes, and submitting, let's say, electronic forms.
Okay.
So the data was there. It was manually taken.
It's quite lagging though, because presumably by
Yeah.
the time I've submitted this form, another 5,000 croissants have gone down the
Yeah,
line.
it goes fast. But with just that, we kind of improved the waste by more than 50% by just being alerted in time enough, right?
So you took a sort of paper-based system, did you, where they'd submit the form, they were able to push the data a bit faster, and you were then able to analyze
Yeah,
it.
and push it to the right people at the right time.
Yes.
So the people that can actually do something about the problem. So I don't know, if the bread is too small, maybe there's some machine to tweak.
Okay.
And then the next step is to remove the manual step.
Yes.
Then we're bringing computer vision,
Okay.
right? We are bringing also laser profiling.
Yes.
So at the beginning of the production line, the dough is flattened, and then we can measure the thickness of that.
So you're putting a bit more science behind it. Okay.
Yeah,
But
and instead
you
of-
build up to it. You build up to this.
Yeah, exactly.
You were able to start very simple and just react faster. Okay.
Yeah, and then instead of having, let's say, just samples of the data with computer vision and laser profiling, it's going to be continuous.
Continuous data.
Every item is going to be measured. So they're going to be able to know even faster when deviation is happening. So that's one example.
A great story about a croissant, and
Yeah.
the fact- just in dollar terms, you know, how much do you think this saved them by being able to improve their quality? Was it $100 a shift, $1,000? Do you have a feeling?
Yeah, I can just have a feeling because
Yeah,
they
yeah.
didn't share.
Yeah, yeah.
But my feeling is, I don't know, millions per year.
So you made them a lot of bread. You made the bread maker a lot of bread.
Yeah.
Yeah.
It's a big company, though.
Yeah, yeah, okay.
It's a big company.
That's a great example.
Yeah.
So that's continuous flow. What about, do you work with any manufacturers? A lot of people, are making metal, cutting metal, some things are not so continuous, they're more discrete processes. Have you worked in that kind of environment? I used to have a machine shop in the UK, so we had lots of problems, but, and when you'd say to me, what kind of data have you got? Have you worked with a machine shop?
Less,
your
because most of the time, the ROI is bigger for continuous processes. Because it goes so fast, you can, you see what I mean?
Yes, I do.
If you don't act right now, it accumulates, right? Whereas with shops like what you describe, it's manual, so most of the operators, they kind of are aware of the quality they're doing, right?
And a lot of the time, sadly, the work is sitting around as work in progress,
Yeah.
actually not doing
It's
anything.
more, it's more process optimization rather than continuous quality stuff. We have worked with equipment builders. For example, we worked with a company making equipment for dairy farms.
Okay.
So mostly for manure management, and also for feeders for the cattle. So we help them add an intelligence layer on top of their equipment so that the equipment brings more value to the farmer.
So what kind of intelligence are you giving the equipment?
So for example, let's say in manure management, you separate the liquid from the solid.
Okay.
Okay, and then the liquid can be used for sending to, not sure how to say that in English, but let's say gas, natural gas manufacturing.
Okay.
Right?
Yeah.
And then for the liquid part to be used for that, it has some characteristic, very precise, and for this, it needs some specific food intake. So the cow becomes the factory.
Huh.
Okay, so we since they control the food, and they can look at the output literally.
Yes.
They can with AI, you can have a feedback loop saying, okay, if when they eat that, it's less. We need that kind of ingredient in the liquid part, and then you can improve that.
Close the loop. Interesting.
Yeah.
Well, I guess. So again, it's a continuous process, albeit it's a biological one going on here with the cow being the factory.
Yeah.
But interesting how there's the same analogy. So by feeding the cow the correct diet, you get the right output that is literally a value stream, literally for the customer. Fascinating.
Yeah.
So you're how do you grow your business? How do people come to you? How do they get to know? Is it all word of mouth?
So let's say before the pandemic, it was just that. Phone would ring, and we just had new customers every now and then. Let's say in the last few years, we had to adapt, and we developed full BDR strategies and digital campaigns and everything to get to customers. Trade shows are a good way also to meet potential customers, and sometimes also partners that can become channels. So that's pretty much how we do it. We have some, let's say, spontaneous potential customer that come to us through our website, but it's mostly through really thorough lead generation strategies. Yeah.
But the thing I immediately sort of take away from your approach is that you're not just pushing sort of one solution for a potential customer. You're really trying to understand, as you say, what's your pain, what's your data, what's the potential value that we get here.
We try to understand what are the pain points and what are the opportunities to really make them more competitive, more efficient. And there's not thousands of solutions. There's families of potential solutions that we can apply and adapt. So it's more like patterns that we adapt. So for bread, it's not the same thing as for, screws, right? But it's similar concepts we adapt for this. We also work with defense contractors. For them, we start, let's say, more upstream, because most of the time they have been in a posture where cloud is not possible. So a couple years ago, it was not possible to work with D&D with the cloud. Now, in recent years, it has shifted from no to you may to you have. You have to. So we help them first build a
What can we just unpack that? Why that shift from no to you have to? That's quite a big shift, isn't it? For an organization that moves very slowly. So why did they make the shift? Yeah.
So I think the reason why they make the shift is they realize that they will be able to move faster with the cloud. It gives them so many more possibilities. You have, let's say, level of abstractions in terms of services that are available in big clouds that you cannot do that you have to do yourself. It's more like a DIY approach when you have your own data centers. right? So let me give you an example. When you build your own data center, you have to manage the purchases of the hardware.
Yes.
You have to decide what operating system, what versions, and what libraries and software you put in it. And then you need to decide, okay, I'm going to virtualize the servers so that one server can be seen as multiple virtual servers. So you add layers of complexity that don't bring value.
Right.
All these things, they don't bring value. It's just the minimum you have to do to start bringing value. And then ultimately, you build applications, you build AI. But then you still start from scratch for doing that. Whereas if you go, so NGen is an AWS partner. So I'll have a bias towards cloud and AWS, just a disclaimer. But with big clouds like AWS, you have level of abstractions that would take years for you to make with your own data center. So you have what we call serverless infrastructure, where instead of having to manage servers to build your application, you just push the functional code, the business logic code to the cloud, and it scales automatically your application, right? If you want to build machine learning, train machine learning models, then there's tons of services that for typical patterns that you just give your data and it trains them and optimize the model by itself. Whereas if you want to do it by yourself, you need to put a big pipeline of machine learning model training. So it's really the pace at which you can go when you use cloud computing. It's just like multiple order of magnitudes in terms of speed. So the big prime contractors, now they're moving towards the cloud. They want to embrace cloud, just like what we had our customers do, let's say 15 years ago. So the patterns we see in those customers that they're just starting their journey, right? And then the first step for them is to build, in our case, an AWS enclave where it is, let's say, military grade, defense grade.
Okay.
And AWS and I'm pretty sure other big clouds are all, let's say, being approved by federal entities and authorities. And they demonstrated that this can be used as a sovereign and private and secure enclave for the defense in Canada. So once we do that, then we can start building, let's say, AI application or maybe more regular web and mobile application as well. Yeah. So with defense, it's really, we start a bit, well, it's not true. You have to do that also for manufacturing.
Yes, yes.
But it takes an afternoon build the enclave for a manufacturer, and it takes months to do it for military grade, because you have to go through a very thorough audit process from the authorities. You need to show evidence that security is being taken care of.
Will this, you talked earlier about how, you know, with the abstractions in the cloud, it can do things for you. Will the cloud be able to build secure enclaves by itself going forward, that it won't take months, that it'll take minutes? Or?
The time to build the enclave that can be assessed is not that long.
It's the assessing that takes the time, is it? Yes.
Exactly.
It's still the humans in the loop.
Yeah.
Okay, I imagine. Okay.
Maybe it's a few days. If you take the, let's say, let me phrase it like that, like a vanilla defense sector structure, it's maybe a day or two to build it. But then, yeah, the assessment is long. And sometimes organizations have their own way of doing things. So, okay, we want this networking infrastructure connected to our on-prem services. So we add on top of that. And what that allows them to do also is, because they can't use ChatGPT or Claude from Anthropic, because those tools, they talk to the US. So data that is sensitive cannot leave Canada.
Okay.
So what this allows them to do is to use the LLM, the models on AWS in their enclave. So they can leverage the same tools that we all use, but in a defense grade manner.
you say that very magnanimously, the tools we all use, but I know on your LinkedIn profile you say, you have a real passion for coding.
Yeah.
Can you talk to me a little bit about how the advent of tools like Claude and that has changed how you work? Is it for the better, for the worse?
Funny, I've been asked the same question this morning, and I always say this: it's both exciting and scary.
Yes.
But the exciting things are that I feel that we can develop and deliver more value faster with equal or greater quality. So that's super exciting. One thing that we had to let go as software engineers is coding is over. We don't code anymore. We are architects. We verify what the AI does. We review the code that it generates, but we don't code anymore. It types 100 times faster than we do, and it knows more the libraries and the tools than we can ever do. What they are not very good at is creativity and thinking about the right architecture. That might evolve, but right now they're not there. So the example I like to give is recently we took a project and we evaluated it with our not that old, let's say, estimation process. We came up with a number, and I said, I think we can beat that with AI. So then we bid a little lower. We won the project, and then we did it, and we made it 7 times faster than our original estimates.
Wow.
So, and what I tell to my team is that every line of code that we ship, even though it's the AI that wrote it, you are responsible for it. So you have to be sure that every line, you have seen it and you agree with it. So the only thing that takes time right now is pretty much that, the code review part. So at some point, AI is going to be better at evaluating itself, but right now we don't feel we can rely on it.
Because presumably if I asked ChatGPT or said, what do you think of my code? To say, I think you've done an excellent job. Because of course they are quite sycophantic sometimes.
There's a way to work around that.
Okay.
So
how's that?
It's really simple. You say, here's what I did. What do you think? I want you to challenge me. I want you to tell me where I'm wrong.
Okay.
I'm looking for my mistakes.
Okay, so it's this old thing where I think somebody was told for an acting class that they had to go and find a pin in a curtain on stage, and so they had to go and act this, and they did it. And then they were told, no, there's really a pin there. You have to find it. And then the way they approached the problem was completely different by, so as you say, by saying, I think I've made mistakes. Tell me what my mistakes are.
So you have to tell them how they can be, because they're kind of what's the word, complacent?
Yes.
So you have to twist the mind, if I can say it like that, so that they can be complacent the way you need it to be.
Yes.
Right? So tell me where I'm wrong. I know I'm wrong. So tell me I'm right that I'm wrong.
Okay, interesting. And do you I don't even know, I think I do know what it is, but vibe coding, do you vibe code at all?
That's what I meant by we don't code anymore.
Okay.
So we tell the AI what to do, and then it codes.
But then you'll review.
Or we review every line of code.
And do you find, like, my own very limited experience trying to build a capability map using Zoom charts and asking for it to be coded, was it started to, as you say, develop an architecture. It developed a solution, but because I didn't really understand what it was doing, I then found it may build you something that you're now trying to fix. And there might have been a simpler solution that you didn't have to fix. And I suppose that's still where your expertise comes in evaluating, you say, the architecture. Can you structure the vibe coding to try and give you the architecture you want?
Yeah, so there's two, like, maybe you've heard about Lovable or that kind of tool. So it's really a black box. You just speak to the AI and it generates wonderful UIs and web application and mobile applications. And for anyone that has never coded, it's an aha moment for them. Now I can build.
Yes.
And it's true. But it's still, it can work at small scale for prototyping. It's extraordinarily powerful. But when you want to build complex system that you want to be able to make it evolve in a way that it can scale, you can add features, then it quickly become like a big spaghetti.
Yes.
Right? And it's hard to make it evolve. And
that was exactly my experience.
Yeah.
Big spaghetti, yeah.
So the way we do it is, in the process, first step is agree with the requirements with the AI. So that's an interactive process. Here's what I need to do, functionally, the business aspect of it. And then this is very, and I tell the AI, don't make any assumption. I get to decide, right?
Okay.
You can suggest, but you don't decide. Then the next step is more designing at the high level, the technical aspect and the architecture. I don't want to know exactly the lines of code, but just the big parts, how they interconnect together. And then when we have that, I let it write the codes. And then when it's done, it can take 15 minutes, an hour. I just let it run. And then when it's done, I come back and I review what it has done. So the part that took earlier in previous years a lot of time now takes an hour to do. But the part that where we bring our wisdom on what to do, the what and the why,
Yes.
this is still something we have to bring in. The AI is not good enough right now from my perspective, for complex system to do that. And it makes enough mistake that you need to have the review phase with it. So again, it compresses a lot, but it's not just, hey, give me a system that does this and this and this, and you can just push a button and then it works. We're not there yet. We might come to that, but we're not there yet.
So NGen is still very much a people-oriented organization. You're very concerned with your customers as people, but also how you work as well in terms of reviewing, being careful, having ownership of
yeah, because we're delivering business-critical systems. If we let AI do it, and then let's say 5% of the time it creates, I don't know, wrong orders on the factory floor, or it doesn't detect specification deviations, then the customer is not happy, and he's in his right to not be happy, right? So yeah, quality is super important.
And just finally, it's been a great conversation. Thank you, Guillaume. I really enjoyed it. I thought this was going to be like going to the dentist, and I wouldn't enjoy it, but I have. You're on the board of AI for manufacturing,
yeah.
And I think you're quite passionate about how Canada can build more. What's your vision? What does Canada need to do? How are you trying to use AI for manufacturing as a kind of, is it thought leadership? How do you see that not-for-profit helping? Is it a rising tide lifts all ships here in Canada? What's your view?
So I think right now, Canada, among, let's say, the big Western countries, we're kind of a lagger, right? We're super behind, and our manufacturing organizations seem to be slow to adapt technology and AI. So an organization like AI Frame, for me, it's educating, explaining to manufacturing companies what's the art of the possible. Imagine that you have all your data and you have a superhuman playing with this data. What could that person do? Then you can do it with AI. So I want them to understand what the possibilities are and figure ways to make this accessible to them. So AI for M is a community in NGen, right? NGen also gives grants to build AI systems for manufacturing. So educating, giving access to the grants. AI for M is also some kind of one of the mission is to match let's say, the demand with the offer, right? So we're a service provider company. We have services to offer, but there's other members that are service providers that offer different kind of services. So it's some kind of matchmaking also. So education.
Will AI play a role in that matchmaking, do you think?
Yes, I was discussing this with Nicole, the person that coordinated this group, and we were discussing that, how we could leverage AI to make manufacturers find the right partners, find the right way to get access to grants, understand the use cases. Imagine you can chat with an agent and say, here's my challenges, and it proposes solutions, and then you could have access to this grant. And by the way, there are providers in the ecosystem that do this and this that might be interesting for you. Do you want me to put you in contact with them? So yeah, AI could play a role for sure.
In the art of the possible.
Yeah.
Guillaume, it's been a fascinating chat. Thank you so much.
Thank you for having me.
Thank you, everyone.
Thank you.
Story. Yeah. Good afternoon, everyone. Welcome back to the NGen Conversations podcast, live at Hannover. Here we are, thanks to the York region. I'm Mark Kirby. I'm going to be your host for the next 25 minutes. and I'm joined this afternoon by Kazem Zandi. You're the CEO and founder of OSCP, which stands for One Silicon Chip Photonic. Is that right?
That is correct.
And this all began with your PhD work. Tell us, if you don't mind, take us back to your original PhD and what problem you were trying to solve there, if you don't mind.
Yeah, sure. Glad to be here. So during my PhD as a photonic student, we had a project with Canadian Space Agency where they were looking for sort of navigation sensors for microsatellite navigation.
Okay.
And the sensors needed to be photonic because of the environment in the space requires the device to be photonics. So at that time, for 5 years, I was working with Canadian Space Agency. What we developed was a gyroscope, which was based on the combination of mechanical and optics, meaning that mechanically we could modulate the light, and from that we could measure the rotation.
So we didn't have spinning momentum wheels like in an old-fashioned gyroscope, but there was still some mechanical motion, but light was being modulated by that mechanical motion. What are the issues with that, and how has the concept evolved since then?
Yes. So spinning wheels, they are like 50 years technology. Now they have transformed those mechanicals method of measurement onto a chip. So there are actually exist some chips that are mechanical, very tiny movement inside the chip. But the problem with the mechanical modulations is that it can wear out over time. And also they're very sensitive to shocks, vibration, and temperature changes, which are not desirable for harsh environment, especially space defense and those applications.
Okay.
Yeah. So after the PhD, then we soon realized that we need to get rid of the moving part for those problems and purely build a gyroscope that has absolutely no moving part, but also is more accurate than the mechanical gyroscope, and that's how OSCP was born 10 years ago.
It sounds like almost an impossible mission to try and build something even better with no mechanical movement. How did you get the inspiration to, develop the product that's in your hand now? Did it come to you one night in the shower, or how did you transition from mechanical movement to no movement at all?
Yeah, actually, the physics is not new. There were.
It rarely is.
Yeah,
if we're honest, yes.
Yes, true. But there are the product in the market called fiber optic gyroscope, where they don't have moving part either, but the light goes through a big coil of optical fiber.
Okay.
And that makes it very bulky and very labor intensive. So that's why the size and the cost is tremendously high, especially for application where, let's say, for example, you're using small robots or a drone. You can't really use that big, bulky, expensive product. So what we said is that, all right, let's see if we can miniaturize that product.
Okay.
So that's how we basically came up with the idea of the miniaturization of the already existing product in the market.
And we're going to have a very ambitious go now, Kazem, at explaining. Is it called the Sagnac effect?
That is right.
Just have it. Do your best. If people are just listening here, they can't see our hands. But
sure.
How does it work?
Sure. So basically, if you inject light in, let's say, in a loop or in a coil or a ring, in two opposite directions.
Yes.
One clockwise and the other one counterclockwise. When there is a rotation, what happens is that due to the Sagnac effect, which was invented by someone called Sagnac, obviously, the light that is rotating in direction of the rotation experiences longer length.
Yes.
And therefore, when we combine those light, one light has a longer length, therefore interferes with the other one, and from that interference, you can measure the basically rotation.
Fascinating. Okay, so it's in some ways a very, like all the best ideas, it's a very simple principle, but then presumably the manufacturing, how do I miniaturize this onto one chip? How have you gone about doing that?
Yeah, that's obviously
that
the
was
concept.
10 years ago, and where you are now.
Yeah, so the concept sounds simple, but when you want to manufacture that on a chip level, then you face tons of challenges. For example, how are you going to basically inject the light into the chip? There's a lot of challenge there. How are you going to integrate the laser light source on it? And it's not just light, and there are other components inside. There's electronics. There's the basically measurement part of the whole system. So you're actually building a whole system, but the chip is basically the brain of that gyroscope. So what we have done over the past 10 years, we've been able to inject the light into the chip and measure the rotation accurately. To give you an idea how accurate this could be is that the Earth rotation, the magnitude of Earth rotation is about 10 degrees per hour.
Right.
And what we can measure is 20 times smaller. So we can even measure a rotation that is 20 times smaller than the Earth rotation. That's how accurate it is, thanks to light principle of light. So getting that chip in a scale at the very low cost by integrating other component is a hard task. So we had to go through multiple iteration of the chip, measure, oh, this is not working. For example, one of the aspects that was really challenging is to get the what is called optical loss of the chip down.
Yes.
Meaning that the light doesn't die within the chip and stays there for a long time. So this requires a lot of material engineering and assembly and testing.
And all of this is being done in Canada, is it? Do you actually build the chips at your own facility? Do you partner with somebody? How do you do one silicon chip photonics? What's the partnering that you go through to do that?
Yeah, so we are a fabless company. That means we don't own really equipments to build the chips, but we do work with partners. One of our proud partners are actually based in Quebec, Bromont, called C2MI. Mm-hmm. We do the prototyping there. And
CTMI is a kind of Canadian jewel, isn't it, that people don't realize what a fantastic facility we have and capability that we have there.
Absolutely, yes. Absolutely. A lot of, as well as Teledyne also, which is a really production facility. C2MI is kind of the prototyping level of the Teledyne also. So we could build chip in Canada, basically. And then we get some other components like the laser in Europe. So the supply chain basically remains within Europe and Canada. And that gives us the benefit of being what is called non-ITAR company. This is extremely important for defense application. If you build or ship or sell to United States for defense, you will be restricted to ITAR. We are not due to the supply chain as well as being Canadian.
And the actual product, you're holding it I'm not sure if this is the smallest version that you do, but this is everything here that would navigate your drone. What are the capabilities that you're holding in your hand there?
Yeah, so what you see here is not just a gyroscope. It's called IMU,
Inertial measurement unit.
which stands for inertial measurement units. And what inertial measurement units is that it uses accelerometers in 3 dimension
Yes.
and 3 gyroscope, as well as an inclinometer. So what accelerometers does is that when the vehicle moves, it can detect the speed of the vehicle,
Yes.
and the gyroscope obviously detects the rotation in 3 dimension. That means every dimension the vehicle moves, you can
So
detect it.
I have 6 degrees of freedom, so I need 3. I need an XYZ accelerometer and an IJK gyroscope, and then I can figure out everything that vehicle has done. Is that right?
That is correct. That is correct. And indeed, this is our smallest IMU currently. And we are actually proud to be the only manufacturer of IMU in Canada. So nobody else is doing this.
Can I have a-
Sure.
And it is literally the size of a matchbox.
Yes.
For those of you who ever
And
grew up with
and,
matchboxes.
and just to compare with the fiber optic gyroscope that I
Yes,
mentioned, the fiber optic gyroscope is the size of grapefruit.
Right.
So imagine
And the weight
how
of
much-
the grapefruit as
Yeah.
well, I imagine.
Yes.
Yeah.
So that's almost like 10 times.
We're the size of
reduction.
a grape, aren't we? Pretty well, yes.
Yes.
A large grape, yeah.
Yeah.
Fantastic.
Yes. But we also do the software inside, so it's not just the hardware. Or we build the software.
So it's a complete sovereign capability, effectively, certainly a Western capability. It's non-ITAR. And you probably can't tell me, but are these units going on to presumably Canadian vehicles within the defense sector? Presumably land, sea, air. The proliferation of new platforms is huge, isn't it? And presumably, many of them need to be autonomous in GPS-denied environments, and that's presumably that's why you need something like this, is because you can't rely on GPS anymore. Is that right?
That is correct. So, usually when you want to navigate yourself, you use your cell phone, right? You
Yes.
go to Google Map, you say, I'm here, I want to go there, and it tells you where to go because it's connected to GPS. But the problem is when there is no GPS, what are you going to do? And that's what it does. It can cover for the GPS. For the application, it can be used anywhere. Basically, what we say is that any moving vehicles that requires a navigation, it needs an IMU. From drone to robots to tanks, helicopter, aircraft, even turbines. And that's not the only application. The other application is for health and monitoring of the machinery.
Okay.
So, for example, for the turbine, we're working with a company where they want to monitor the health of the blades of the
So
turbine.
we'll be looking at is it vibrating?
Vibration.
Yeah, okay,
Yeah, because you don't want to have a tornado and a lot of vibration, and then that damages the blade. So you want to detect that earlier to prevent that. But speaking of defense, we just won actually a contract with the Defense Canada. So our device is going to actually go into a lot of defense equipment soon. So
Congratulations on that.
thank you.
So let's switch gears for a second, because you're obviously a brilliant scientist, but you're now charged with trying to be a brilliant businessman as well, with trying to bring OSCP to grow it. How have you been doing that? And kind of tell me a little bit about the people journey that you're on. How does the company scale? We've talked about the technology, the product, but how do you grow the company and the people you have within it?
Actually, I'm glad you brought it up. Transitioning from an engineering mindset to a businessman is extremely difficult. So I struggled a lot at the beginning for a few years, because I used to think like an engineer, but you need to think also like a businessman. So it took me a while to really transition from that. We started with hiring a couple of people. We didn't have a lot of money, so we were just doing simulations until we got the first product. Then we got lots of grants actually from the government, several millions of dollars. Then we went through the fundraising, investors got a few $1 million, still keep going. We just actually closed our Series A round of $6 million US.
Wow.
So with that money, obviously we could hire more people, expand our facility. So we do also test. So our capability is not just design, but we also do the testing. So when we get the parts, engineer has to assemble the parts, build the system, and then test it. So we need some infrastructure for testing. So we are now about 15 people and projecting to be 25 by end of this year.
And whereabouts again are you based? You're
We are based in Montreal.
in Montreal.
Yes.
And do you find attracting people to the company? Is it easy? Is it difficult getting those skills that you need?
Actually, Quebec is one of the photonic hub in North America. So there are lots of talents there. Most of university, they have photonics. They actually, they have engineering physics program that educates photonic people and graduate photonics. So we don't have issue with hiring and finding the good engineers. But at the senior level, it's a little bit challenging. So sometimes we end up hiring people from the west of Canada or the United States. But in terms of talents, it's pretty good place to find.
That's awesome. So we're going to be seeing this. Well, we won't be seeing it, I'm sure, because it'll be buried somewhere. But where do you go from here? You know, you've done your Series A. You've got a contract with the DND. What's next for OSCP?
Mm-hmm. Great question. So the cost of the product is still a challenge.
It's always a challenge. But we're in the right place, aren't we? We're in, this is all about manufacturing, isn't it? So is that going to be the key to smarter manufacturing, different way of manufacturing?
Yes. Yeah.
Innovation?
So providing product to defense and aerospace is great, but it's not a mass market.
No.
So if you want to penetrate into mass market like robotics, even humanoid or drones, you need to get the cost down. And the way we will do that is that currently the laser is not on the chip; it's off the chip. So we have actually 3 modules inside this to build the gyroscope, and that adds cost. So we want to go all on one chip, meaning putting everything on one chip. Hence, one silicon chip photonics. That's why we call ourselves one silicon. So that's basically.
I'm glad you got your corporate mission fully aligned. Yes.
So that's the mission, vision of the company. Within the next 2-3 years, we believe that we can get the cost down about 15 times. So at the range where